Let's talk about why space telescopes image with different wavelengths of light. Hubble observes with visible and ultraviolet light and a little bit of infrared. JWST specializes in infrared, and Rubin is mostly visible light with a little bit of infrared and a little bit of ultraviolet. When we look up into the night sky, our eyes can only see a very small slice of what's there. That's because visible light is only a small part of the electromagnetic spectrum. And objects in space give off energy in lots of different wavelengths, and not all of them are in the visible spectrum. And each wavelength tells us something different. Visible light shows us what our eyes can see: stars, planets, galaxies, and glowing clouds of gas. But infrared light can pass through dust clouds that block visible light. That's why JWST can use infrared to see past the dust clouds and see what's happening behind it. Infrared also allows us to detect relatively cool objects that don't put off a lot of visible light. Going to shorter wavelengths like ultraviolet and X rays let us see some of the hottest things in the universe: incredibly hot gas, stellar explosions, and things swirling around black holes. On the other end of the spectrum, radio waves allows us to see cold clouds of gas, pulsars, and even the leftover glow from the early universe. And sometimes astronomers look at a very specific wavelength. That's what I am doing when I do H alpha imaging. I am looking at the hydrogen alpha wavelength of light that allows me to see the structures on the sun that we can't see in visible light. It's kind of like having different types of vision: X ray, infrared, radio waves, visible light. Each of them give us a little bit more information. And when you combine them all together, we can get a complete picture of what's going on in the universe.